Hello everyone. So today we will see about a 555 IC. You can see a 555 IC in front of your screen. So it is used as a multi-vibrator also, monostable, bistable and astable also, and it is also used in the timer circuits. Now let us see the internal diagram of this 555 IC. So this is the internal diagram of a 555 IC. You can see these are the two comparators. You can say that comparators or differential amplifier. So, and this is a RS flip-flop, and this is a discharge capacitor where we will apply a discharge capacitor externally, and this is a transistor which will discharge this capacitor, and this is the output, this is the control, this is the trigger. Now let us see the working of each and every compartment, each and every department. This is what? This is the potential divider. Now let us see. This is an op-amp. I hope that you understand it. See the working of RS flip-flop. If set, S means set, is given 1, then what will happen? Then Q will become 1 and Q bar will become 0. Why? Because if set is 1, set is high, then Q will become high and Q bar will become 0. If reset is given 1, then Q bar will become high and Q will become 0. So this property must be in your mind, that Q and Q bar will always just opposite to each other. Means if Q is 1, then Q bar will be 0, and Q bar is 1, and then Q will be 0. Now let us see the transistor. What is the working of transistor? I have already explained you a whole working of a transistor in my previous video. If you haven't watched it, you may go there, or I am simply explaining it there. If you will give the voltage to the base of the transistor, then this transistor will act as short circuit, and the collector and the emitter terminal will become short circuited. And if there will be 0 volt or low voltage, then what will happen? This will be acting as open circuit, means there will be no contact between the collector and the emitter. Okay, for full detail you may check my previous video of automatic motor, in which I have given the whole working of transistor, relay. So this is a voltage divider circuit which is used inside a 555 IC. You can see that the voltage VCC and the ground here. So the equal resistance are added in series. The 3 resistance are added, R, R and R. These all are in series, and if you will find the voltage, if you will measure the voltage here, then what will be the voltage? You can simply find by the voltage divider rule, and here the voltage is V2. Now let us see the voltage divider rule. Voltage divider rule is simply this. If we have to find the V2, then what will happen? We will just multiply VCC into R. Why? Because VCC is the total voltage from ground to VCC, and R is the resistance which is coming between the ground and the voltage which is to be measured. Okay, so we will take VCC upon total resistance 3R into resistance whatever across which we have to find the voltage, which is small, which is R. Then we will multiply it, and R will get cancelled, and we will get VCC upon 3. In the same way, we will get the value of V1, VCC upon 3R into R plus R 2R. VCC upon 3R into R plus R, you will get 2 by 3 VCC. Okay. If the voltage in the trigger pin, that is the pin number 2, if the voltage is greater than the VCC by 3, because here what is the voltage at the across this R3, it is VCC by 3. This is V2, VCC by 3. Here you are getting VCC by 3. If the voltage at the trigger is lower than the VCC by 3, then what will happen? Then the comparator 2 will give the output as 0. And if it is giving the voltage VCC by 3 and the trigger pulse is high by the VCC by 3, then what will happen? Then it will give 0. Now we will see the pin configuration in reality. You can count the pins from where the mark is there of a semicircle. Just count it from the left of that mark and just continue counting 1 2 3 4, and just 5 is just opposite to the 4, and then 6 7 8 9 10. So thank you for watching this.